talk about plastic to fuel. Now this is a topic that's been talked about for quite a few years now. And people want to know, some people want to know, can you do it at home? Is this something you can really do at home? Can you really turn plastic into fuel? The short answer to that question is yes, but it's not easy. Okay, but today I'm just going to touch on some of the components that if you want to do this, okay, and I'm not giving you advice to do it. This is just me sharing. Okay. So let's just talk about some of the components that you would most likely need. It's quite a lengthy process. I'm not going to dive into what it takes for pyrolysis, which is the first step you would have to do, and to convert the plastic into what's called a crude, and then from there you would convert or distill the crude into what we call distillate products. That would be things like gasoline, kerosene, and diesel would be the primary products that you would normally distill. Okay, so to go from A to B is quite a lengthy process, and it takes quite a bit of know-how to do it. So I'm not going to dive too deep into all that, but I am going to touch on some of the components today of what you would probably need. Okay, so I'm going to look at this. The pieces we're going to look at now are the distillate piece in the beginning. I'm going to kind of start from the end and work my way back. Okay, so what is this thing we're looking at here? Well, this is what you would see like in an automobile for either AC or like an intercooler radiator. There's two radiators here. Okay, I happen to have it mounted on a stand. You can see the little triangular stand right on both sides, connected with some threaded rod there. Okay, and there's the other side with the fan. Makes sense now, right? The fan's bolted on there, and I think this is a puller. It pulls air through the fan or through the radiator. Okay, radiators are also known as heat exchangers. So why would we be using this? Well, when you're doing distillation, you have another component called a condenser. Okay, and I don't have that in front of me right now, but we'll talk about that in another video. But a condenser is going to be used to convert vapor gas into liquid gas. Okay, and in that process you get a lot of heat. Okay, and so you need a generally the way we cool that off and provide coolant running to the condenser, so the condenser can extract heat out of the process and exchanges the heat like this out into the atmosphere. Okay, you can see there's an inlet here, and I have it wrapped up right now. There's an exit right down there. Okay, I happen to have a rag around it because I've used this before and it's kind of still dripping, so we're just going to keep that rag on there for now. All right, so that's that. Now what's this right here? Well, this is a laptop battery brick. It's a power brick you plug into the wall. Now normally you put this in your car, right? This is automotive industry stuff. You put it in your car, in your 12-volt system, and your car would run this power to this fan. Okay, but since this is outside of a car, we got to find a way to power it, and that's what this is. This is just a laptop like electric brick that happens 120 volt from the wall, and then outputs the right amount of voltage and ampage to run this fan. So that's what you're looking at there. Okay, and there's some other components to go with that I don't have shown right now. Okay, so that's just one piece. Remember, we're talking about the distillate portion of this whole process, right? So this would be, again, this is the components we're looking at here are all components that you would use to take the crude oil and help make distillate products, or products that you could put in your vehicle, your diesel truck or your gasoline car. Okay. So what's this thing down here? What is this? Well, this is known as a fuel pump. Okay, this happens to be one that's used usually for diesel. Okay, and these are fairly inexpensive. Just got two wires that run in there. Okay, and I got two of them here. I got one right here too. Okay, and you can see a bunch of hose here. There's some laptop bricks buried down in there as well. Okay, because these components, just like this radiator, run off of 12 volt voltage. So you have to match the right voltage to run these. So what are these for? Well, these hook up to these lines here. Okay. Well, they're just fuel pumps or diesel fuel pumps, small ones, and they help circulate the coolant through this entire radiator and out the bottom. So, you know, in, out, sometimes it's in this way, out. You can go either way. It's bi-directional, whichever way you want to use it, okay? I built myself a little stand so it could just sit on the ground here in the garage, okay, or wherever else I might be doing my operations, and just let it heat exchange out, okay? So that's what's going on there. Pretty cool stuff, right? And that type of hose is called silicone, and this is fairly high temperature silicone hose, braided hose. And specifically braided. If you look closely, you'll see the braids. I think maybe you can see the braiding in there. See the white like slashes? Those are braids in there. That helps keep the line hose strong, keeps it from getting flimsy when it's all heated up. Okay, so that's why I always buy the braided version of it. Okay, that's a project for gravity electric generator. We'll talk about that. I haven't touched that in a few years, but I still haven't forgotten it. Okay. Let's go over here. Let's talk about this for a second. Sorry about the light, but that's the way it is. This is what we call a solid state relay. Solid state relay. This one happens to be an SSR 25DA. Okay. I'll let you look that up if you want to, but solid state relays, very useful. They basically control the flow of current, electrical current. They turn on, they turn off, they turn on, they turn off. They let power flow to whatever component you want. Okay, based on a condition. Based on a condition. What condition we talk about? Usually, for these kind of things, you have what's called a pit controller. Okay, it helps control, and there's a pit controller right there. Okay. All right. I've used all these components before on other distillation processes, but basically the pit controller, you can see all the terminals in the back. They you set this to certain temperatures, and there's parameters in here you can set, and it'll tell this when to turn on and turn off. Okay, or let electricity flow or not flow. So how does a pit controller, how does it know when to send the signal to this to turn on and off? Well, since we're talking about distillation, we're going to use what's called a thermocouple. Okay? And that's basically a temperature sensor. Okay, sorry about it being a little bit out of focus. But you stick that into whatever you want to read temperature for. It sends a signal along this wire. All this wire here. Okay? And the end of it's got these two connectors on it. See it right there? And those hook up to the back of this this pit controller on the back. Okay, you hook them up right there. Here's, you got to read the instructions, and it's been a while since I've done this, but basically it's not too hard. You can get them on the internet and figure out which terminals to do what. Not too hard. So you hook that up, okay, and after you get everything wired up, basically this pit controller has smart logic that says, hey, solid state relay, let the electricity flow. Okay. And we're going to flow this electricity to what's called a heater mantle, okay, for laboratory type of equipment. Okay, and that laboratory type of equipment I'm using is basically a flask. Think of a lab. You might know them. Let's see, flasks or glassware, right, that you use in lab settings. Okay, so that's going to, we heat up the flask. We got crude oil in the flask. We've got a column. And I'll cover that in another video. I'm not going to dive too deep into that, but this is going to control the heat, the heater that turns on and off to heat up the flask, and in the flask is going to be crude oil. Okay. So how do we get the crude oil? Everyone wants to know, well, how do you get the crude oil? Come on, man. Come on, get us. Those components are nice, but how the heck do we actually get the crude oil out of the plastic? All right, let's talk about it. Let's talk about that. What is this right here? Okay. Let me move some of this out of the way. Okay. So this is currently my receiver setup. Okay. And I need to go to a bigger receiver because this one works okay, but it doesn't handle the highest of temperatures. So basically you see this line here, right? This stainless steel line comes down. It's wrapped right now in what this is called fiber, like a fiber blanket. Okay, ceramic blanket. That's what I'm looking for. This is called ceramic blanket. It's has a very high resistance to temperature. So it can handle some really high temperatures. So much so, I could put zip ties on the outside, but inside there you could be running at hundreds of degrees. I mean hundreds. Like 5, 6, 7, 800 degrees could be running. And the ceramic blanket will actually protect those zip ties from breaking. Isn't that amazing? So anyway, that's a stainless steel tube in there. It comes down. Okay. Goes into this receiver. Right now I got the elbow disconnected because I ran a batch a while back. Okay. And what comes down into here is going to be the crude. And high temperature crude is flowing down into this cylinder. Okay. And this is all made of stainless, and you can see there's different adapters on there and whatnot. And I won't dive into this just yet, but basically the crude flows down into here, and half of this is filled up with water. Okay. So this acts both as the receiver and the condenser, which is a little unusual. In most industries, we don't do that. We don't condense and receive in the same a piece in the same component in the same container. That's unusual. There are other ways to do this where you don't have to do it this way, but this is one of the easier designs. Okay, it has some drawbacks which I won't dive into now, but basically the gaseous state comes down here, starts to condense while it's in this tube, and fully condenses down into the water. Okay, so this pipe you're seeing right here actually extends through this cap and comes down about halfway into here. Okay. And then gases come out the bottom of that, and they condense inside the water. And then when they condense, it turns to a liquid, and liquid crude, and the crude floats to the top. Okay. And then I got some valves down here at the bottom. Okay, which is a little hard to see right now, but I got some valves down there, and we open up those valves and we drain the crude out. Okay. This little port right here helps release gases that cannot be condensed. That'd be like CO2. So gases that can't be condensed would come out of there. Okay. All right. So that's the receiver. All right. Now, there are a lot of ways you could heat your plastic. Okay, but the one thing you want to be careful about is, and we're going to look at this right now. Where do we put the plastic? Okay, we put the plastic in this thing right here. You're looking at a little bit of a reflection. That's the garage door going into my house, so ignore that. It's just a reflection. So this is a kiln, okay? And kiln, normally we put artwork in there, right? And we put artwork down in kilns and we heat it up, and then we dry the artwork, the clay, okay? But I'm using the kiln to heat up plastic. And inside there is a stainless steel container, okay? Yeah, don't do this at home. Okay? Yeah, don't do this at home. All right? I'm not giving you advice. I'm just sharing. Okay? Yeah, don't do this at home. There, I said it 3 times. Okay? But inside here is a stainless steel container, okay? And this kiln heats up to really high temperatures. And there's an oxygen-free container in there. Okay? We don't want any oxygen inside the stainless steel container that's down inside. That's what that pipe right there is, stainless steel tube coming up. Everything is stainless inside, and so is the tubes that come out. Okay. So we take this called ceramic fiber board. This is really thick stuff right here. It's really thick. That's like maybe like 2 inches, maybe more, 2.5. Okay. And it's the lid that I'm using, a made-up lid that I made. And on the top up there, I cut out a little semicircles in each side. You can see the split right there, right? That's 2 pieces that come together, right? And that's called the column, and it comes out and it goes over and down to the condenser, okay? All right, so the kiln is what supplies the heat, because there are other ways to heat, but the important part is you have to be able to control the heat to exact temperatures, and you also have to make sure your containment area where your plastic is doesn't have any oxygen in it. If you have any oxygen in your reactor, you're gonna have nothing but white smoke that comes out into here, and you're not gonna get any crude. That's really, really important, okay? So how do we guarantee there's no oxygen inside this thing? down in there. I got a big old stainless steel container like this, but bigger. How do we get the oxygen out? Well, some people use vacuum, okay? Some people push other types of gas, like an inert gas, and push out the oxygen, but you don't have to do that. As long as your container in there is completely welded shut and you have a way to seal it and don't allow any outside atmosphere to get into the container, you're going to be fine if you use this approach. Because the water in this receiver, and this is really key, is the buffer between the outside world and what's going on inside the reactor. Okay? So that's kind of the basics of how you turn plastic into crude, okay? Is it dangerous? Yes, it is friggin' dangerous. Why? Because there's going to be some really high temperatures inside this reactor. And if air, which contains the air we breathe, guys, in the outside world, if it contains oxygen and nitrogen, okay? So I think it's like 20% oxygen. If oxygen were to get inside that container, the temperatures are so high that it could potentially ignite some of the fuel in there, and you would have potentially catastrophic failure. So very dangerous. So as I said before, I'm going to say it again, don't do this at home. Okay. So there it is, and the water in here acts as a buffer, okay? And it replaces the need for a vacuum. All right, so have I run any batches on this before? As a matter of fact, I have. Some of you are going to be surprised. You're going to say, that can't be crude product. That's not what I expected crude to look like. So you see that color? That's a very kind of thick looking, it looks like it's thick, right? You would expect crude to be brown or black, like it comes out of the ground. And that can't be crude. What we're looking at here is called paraffins. This is a waxy substance, and it's part of what you're going to get out of plastic when you convert it to a crude. Okay, but inside here on the bottom, there's other fuels down below at the bottom of this little container, okay? And when you heat this paraffin up, it'll turn to a brown liquid. Okay? And in that liquid, you're gonna take it and distill it. Remember earlier I showed you some of the components for distilling? Okay. So this is what you're gonna get. You're gonna get something like this. Depending on the type of plastics you put into your reactor, okay? But this is one of them. You know, there's only certain plastics you can do this with. So you're going to get paraffins if you do it right. And that's what that thick stuff is. Now if I smell this, I smell fuel in this container. The fact that I got the lid off is a really bad idea, because that means that some of the light volatiles are escaping from this container. But I just wanted to share that with you, and that's what you'll get. You'll get something like that. This is extremely volatile if you heat it up, so do not apply heat to this in an open oxygen outside area like we're in now. Trust me, I've done it. It will ignite and it'll have a huge flame. Okay, so don't be foolish. Don't ignite that. Okay, you want to make sure that those fuels that you're going to extract out of this crude, you want to make sure it's in a controlled environment called a distillation environment. The different type of crude, the mixture of crude you're potentially going to get, let's see, let me get out into the light here. You'll get something like that, all right? And that, you'll notice, is like a very thick, dark kind of crude, okay? You can see there's a lot of water. Why is there water? Because remember, in the receiver, we had water in there to act both as our receiver and our condenser, right? So this was, when it came down into the receiver, was actually a gas, a vapor gas, hit the water, turned to a liquid, and floated to the top. And this is what you got. This is some of the heavier, really heavy fuels. This is like a tarry substance, okay? Now, the oil industry normally drops this out of the bottom of their pots. They don't distill it over the top. So that's the back side of the spoon. You see that gooey stuff right there on top of the... That's it. It's almost like a thick, gummy tar. So that's called bitumen. And bitumen is used in tarring roads, asphalt. Certain tiles that go on top of homes. They call it asphalt sheet, and So this is used the world over to pave our roads. That's what you're looking at there. Okay. So you'll get that in your crude as well. At the really high temperatures, the last, you know, portion of your reaction is going to bring this stuff over. Okay. You see that little? This looks like a lawnmower engine right here. All right, that thing right there. Okay, that thing. Get this bucket out of the way. There you go. So that's a little crankshaft right there, right? That's a gas container, and you can see a couple filters. This is actually a little one-cylinder diesel engine. That's what that is. Cheapy little diesel engine. So I bought one of those on the cheap off of eBay. And after I distill some of the diesel that we're going to get out of the crude, we're going to try to test it inside this diesel engine. If it starts and runs, we know we're good to go. Now there's other things you got to do with the fuel. You got to use maybe some detergents. So I hope you guys really enjoyed this video. Again, yes, you can convert plastic to crude at home.